Hey everyone, it's Bennett. I will be going over AppArmor and HTTPS protocol, as well as the servers that will be using the HTTPS protocol. So first will be AppArmor. So in my research, more or less I found that AppArmor is a security module within Linux that'll protect your operating system as well as any applications from any internal or external threats, and it'll prevent both known and unknown variables from being exploited on your system. And there's no need to install AppArmor as it comes pre-installed, and it'll load by default on most of your Linux distros. So AppArmor utilizes or uses the Mac mandatory access control versus the traditional Unix strategy of discretionary access control or DAC. So what this means is AppArmor will restrict the ability of resource owners to grant or deny access to other resource objects within a given file system. So the security trial is defined, the security criteria is defined by the system admin and is strictly enforced by the operating system. So it restricts the ability of end users to alter the criteria or any of the criteria. So AppArmor also uses profiles of an application to dictate the necessary files and permissions required by the application. And typically there's no need to configure these profiles for each application, um, as when the package is installed or initially installed, it will install its own profile with it. So there are two profile modes within AppArmor. There's complaining learning and enforced slash confined. So the complaining learning profile is a mode that will complain or learn of any violations of a profile, and it'll log those events, such as, for example, if a profile access files outside of the defined scope of permissions, that violation under the complaining mode will be permitted and then logged. So this mode is really convenient for developing new profiles and, and testing any new policies within that profile that you think would be beneficial to your environment. Whereas the enforcing slash confined will mode will enforce the defined policy for the profile, and it'll report any violation attempts to that policy. So there is no warning. It is a definite no. So there are also two rule types within the profiles in AppArmor. You have path entries and capability entries. Path entry will define which files the application can access, while capability entries will decide the privilege a process is allowed to use. So a few hardening recommendations I found for AppArmor was: one, ensure all profiles are enabled and limit any of the profiles in complaining mode. So if you can use the command AA-status to compile a list of all the profiles within your system that are either in complaint and enabled mode. So you can see a complete list of all your profiles and their status, and then limiting the profiles in complaining mode and limiting their usage for only testing purposes, and making sure that these profiles have a specific time period during that testing phase. We'll just ensure there's no holes or no holes open inadvertently and forgotten about. Another hardening recommendation is AppArmor profiles possess the ability to prohibit internet usage for applications. So if there's an application within your environment that you don't want or should not have internet access, you can simply modify the profile to deny internet access for the application, and then reloading the profile will enable that new policy. You can also manipulate folder or resource access, such as denying an application certain permissions to files or resource access. It's an excellent way to reduce any lateral movement within your environment if there is a breach or unauthorized access. And then lastly, I found a command you can use called AA-unconfined. So to use this command, first off, you have to install the AppArmor utils, and you have to run it as a root user. But what it'll do is it'll show you applications and services that have open network ports. and do not have profiles enabled. So obviously anything that's open, we want to make sure has at least some type of protection. Okay, so next up, we have HTTPS. So HTTPS stands for Hypertext Transfer Protocol Secure, and it's a more secure version of its predecessor, HTTP. And it's the primary protocol that's used to send data between web browsers or from a web browser to a website, and it uses port 80. So HTTPS is very similar to HTTP, other than HTTPS utilizes TLS SSL certificates, which is more or less a verification process that'll verify um, whether someone is who they claim to be or not. So the data transfer is encrypted within HTTPS using the transport layer security protocol, which will utilize the asymmetric public key infrastructure. So the more or less what this process involves is a private key, which is controlled by the owner of the website, and then a public key that is available to everyone. So the traffic's encrypted by the public key, and only the private key can decrypt the traffic. And then what this will do or prevent is if someone is sniffing on a network and you're using the HTTPS protocol, that person can see your traffic, but that has no idea of its contents. But if you were using HTTP, the sniffer would be able to see both your traffic and its contents. So next we have IIS. This is one of the servers that will be using the HTTPS protocol, and IIS stands for Internet Information Services, and it's a Microsoft web server, and it operates on Windows operating systems. So IIS servers, it'll it'll utilize multiple protocols for transferring data, such as SMTP, FTP, and HTTPS. And it actually has multiple uses, such as website hosting, logging, request filtering, and native support. And I'm going to go into these a little bit. So website hosting, IIS can be used for application hosting, websites, and Windows Communication Foundation services. The logging portion will retain logs recording regarding critical information for your server and website, such as any performance issues or any usage patterns. The request filtering portion is a module within IIS that can be configured to filter traffic by specified file extensions or URL length and string size. So these scans can actually filter potentially dangerous requests out. And the last one is native support. So this will support Microsoft.NET framework and in turn will improve the ability for developers to construct, deploy, and manage ASP.NET web applications. So a couple hardening recommendations I found for IIS is CGI/ISAPI restrictions. So CGI and ISAPI are two common ways to generate dynamic content or to any native capabilities um, of the IIS server. So the file extensions for both of the files, CGI is .exe and ISAPI is .dll. They're both common for exploits. So restricting the use of these file extensions when not in use is important to prevent any web attacks using those file extensions. Next is filter HTTP requests. So IIS has an extension called URL scan, and this can be configured to filter potentially dangerous HTTP requests through actually rule-based filtering. And then lastly is application pool identities, and this feature runs application pools using unique accounts without relying on domain or local accounts. And then we have Apache. So Apache is another server we'll be using to to run HTTPS protocol. And Apache was actually created in 1995 as an open source web server. And as most web servers, it accepts HTTP requests over the internet and responds with the requested information such as files or web pages. Um, Apache is actually compatible with both Windows and Unix-based systems, so it's not limited to one. Apache acts more as a middleman, and it runs as a software on an HTTP server. So the communication between the server and the client is actually administered by the Apache web server, and it's responsible for the security and smooth communication between both the server and client. So because Apache is an open source um, product, web developers have access to the source code and can manipulate it to their specific needs as necessary, creating a highly customizable product. So Apache also includes large amounts of modules to configure, allowing server admins to turn many features on and off as necessary. Again, just backing the highly customizable product. So a few hardening recommendations I found. One is to disable directory browser listing. So a visitor to a website or to your website could actually see all your files and folders under your root or subdirectory. So disabling the directory listing will actually prevent those files from being visible and exposed. Another is use non-privileged account. So using a non-privileged account to run Apache will protect other running services if the account is compromised. Um, and just so you know, by default, it runs as nobody or daemon. And then lastly, disable trace HTTP requests. So by default, the HTTP request or HTTP trace request is enabled, and it actually can allow hackers to steal cookie information. So making sure to disable this feature will prevent, excuse me, any cross-site tracing attacks. And that is all I have. Here are my references for my research. And again, I look forward to seeing what everyone has to say about what I found, and I look forward to seeing what everyone else found on these topics.